So we want to talk about graphing a quadratic. When we graph a quadratic, it makes a shape called a parabola. Parabola. So if it's opening upwards, it would have this kind of U shape. And if it opens downwards, it'll have kind of like an N shape. But something that's unique about it is that where it changes direction will be called the vertex. Okay? So the vertex is where it changes direction. Where it changes direction. So looking at this, if I read this from left to right, right now it's going down, 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 and whoop, there's my vertex. And now it's going up, 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 up. Okay, so look at this one. Right now it's going up, 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 up. There's my vertex, and now it's going down, 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 down. So your vertex is where it changes direction. Okay. Now, if you'll notice, these little arms are going to be continually moving outwards and upwards. These little arms, or your end behavior, will be going forever downwards as I move left and right. So your domain on this will go forever left and forever right. This will go forever left and forever right. So your domain on a quadratic function is always all real numbers. But your range will be different because remember, do smallest to largest. So I'm going to come up, I got nothing, and then all of a sudden I've got this y coordinate, and now I've got lots of y coordinates. I've got lots of y coordinates, and then I top out. So this is actually called a minimum value, because that's the lowest it's going to go, and this is called a maximum value, because that's the tallest it's going to be. So as I look at my little examples here, we're going to look at how we can use that information to determine what the domain and range is. So this is vertex form. What it means is that you'll have a clump squared plus or minus a number. And then general form looks just like your trinomial in descending order. Okay, you may have to organize to get into one of those two forms, but these are the forms that we're looking for. So looking at this one, what format do I have? I've got a chunk squared plus or minus a number. So I notice up here that the value for h has a sign change. So it says do x minus h. Well, this says x minus, and then I have a 3 here. What that means is you're going to take that out, and it's going to become a positive 3, because it's x minus, cover that x minus up, and you got a 3. Cover the x minus up, and you've got an h. Okay, so change this sign to be a positive 3. So my vertex is at 3, and then write this sign just as it stands. Okay, or that value as it stands. So change this one, pull it out, make it a positive, leave this one alone. So leave it as a positive. So your vertex is at 3, 2. So if I come over here to 3 and go up to 2, now I just got to figure out, does he open upwards or downwards? So you're going to look at your lead coefficient. How do you lead off? So remember that there's a 1 that is implied to be there, and it's a positive 1. So if it's positive, it's going to open upwards. If it's negative, it's going to open downwards. So your domain on this one is going to be all real numbers. We've already established that every quadratic will have a domain of all real numbers. What's your range? Your range is going to be the very, very, very lowest y coordinate. Well, the very lowest y coordinate is going to be at 2. And then I'm going to have y values for the rest of the time. I use a hard bracket for 2 because there's a valid point there. There's not an asymptote. There's not an open circle. Okay, so let's do another one. We have, this is in standard form. I'm sorry, this is in vertex form. So I'm in vertex form. I want to know what the vertex is. So I've got a chunk squared plus or minus a number. So my vertex on this, change your sign, will be negative 3. And then your other one will stay the same. And by the way, if there's not one, if you're missing an h, or if you're missing a k, it's implied to be 0. So if it looked like this, and it was just x squared plus or minus a number, okay, then you would have, your vertex would be at 0. Okay, so what I have here is a vertex at -3, -6. So I'm going to go -3, -6. And then what do I notice? I am leading off negative, which means this thing is going to open in a downwards fashion. So he will look like this. So my domain of every quadratic function is going to be from -infinity to +infinity. Okay, your range is going to be from where? I've got all these y values until I top out at a y value of -6. So from -infinity until I top out at -6. This one is in general form. So we have a different formula to use for the vertex. For our vertex in general form, we're going to use -b over 2a, and that should look familiar to you because it's part of the quadratic formula. Okay, and then once we find that value, we're going to put it back into the function. So take that value and put it back into your function to find out what your y coordinate is. So first of all, what do I notice? I am leading off positive. This thing is opening in an upwards direction. I would like to know what the vertex is. So my vertex is going to be -b over 2a. So that's going to be -6 is going to be a -6 over 2 times 1, which gives me a -3. Take that -3 and plop it back in here to see what his y coordinate is. If you ever want to know what y is, then evaluate x in your original function. So my y coordinate will be a -3 squared plus 6 times -3 plus 4. So I get 9 minus 18 plus 4. So I get a -9 plus 4 is -5. So my vertex is at -3, -5. And we've already established he's leading off positive, so it will open upwards. So at -3, -5, he's going to open upwards. So there's your vertex. So what's your domain? My domain is going to be all real numbers. Okay, what is my range? What's the very, very lowest, or what's your minimum? Okay, I'm going to have a minimum value at -5. The lowest y coordinate I'm going to have is -5. And then I'm going to have y coordinates for the rest of his life. So he'll go up into +infinity. Okay, so we have this one. This is general form. And I know that that leads off negative, so it's going to open downwards. This is in general form, so I need to use -b over 2a to find the x coordinate of my vertex. So it gives me -8 over 2 times -2. So -8 over -4 does not give me 4. It gives me a 2. Okay. So grab that 2. That's the x coordinate of your vertex. Now I need to know what the y coordinate is. So grab that x value and plop it on back in here. Okay. So my x value is going to be a -2 times x squared plus 8 times x plus 6. So I get a -2 times 4 plus 16 plus 6. So -8 plus 22 is going to be, is going to be 14. Okay, so 22 minus 8 is 14. So my vertex is at 2, 14, but I've already established he opens downwards. So at 2, 14, he opens downwards. So what is your domain? The domain of every quadratic function is going to be all real numbers. The range, where am I going to top out at? The tallest he's ever going to be is 14. So I've got all these y values, and then I max out at 14. Okay, so now let's take it a step further. Wrong way. And I would like to know what the equation is in general form of the following quadratic function. So I know I've got a vertex. This is my h and my k. And I know I've got another point. So look at my lovely drawings that I gave you over here. There's an infinite number of points, infinite number of points, infinite number of points. Okay, so we gave you one of them. We gave you the vertex and a random other point, and we would like to know what the formula is in general form. So I'm going to use vertex form because I was just given the vertex, okay? I'm going to use vertex form and this original point, or this other point, and I'm going to find out what that is. So I have f of x equals, and what I'm going to start off with first, remember that general form has an a out front, but I'm kind of going to ignore that for just, actually I'm not going to ignore it. Let's go ahead and do it. All right, so I have general form is a times x minus h squared plus k. So if we notice, remember your f of x, I can rewrite as just a y. That was lovely. So here's a y. So I have a y and an x. Here's a y and an x. I have an h and a k. Here's an h and a k, which means all that's left to find is a. Okay, so that's what I'm going to find first, and then I'm going to plop this stuff in and figure out where to go from there. So what y value do I have? I have a y value of 12. So look at your xy coordinate to find that. So I've got a 12 equals a. I need an x. My x coordinate is a 5 minus, okay, what is your h? So remember when you took it out, you changed its sign. When you put it back in, it should be negative. So it's positive here. Now it's going to be a 5, negative 2. Okay? Squared plus, what is your k value? He is 3. So I've got a 12 equals a times 3 squared plus 3. So I'm going to subtract this 3 off. So, oops, sorry, I just told you what the answer was. Minus 3 is 9 equals 9a. Okay, because 3 times 3. So this is gone. And then 3 squared is 9. And I divide both sides by 9. And I get 1 equals a. So I'm going to take that information on a new page. And I'm going to figure out, now that I know what a is, I can use just the vertex information and FOIL stuff out. Okay, so coming back over here, that is so the wrong direction. What is happening? Okay, so I have y equals a, x minus h squared plus k. So I use the xy coordinate for the simple purpose of finding out this. Okay, well now I know what that is. It's 1. So I'm going to leave my x alone, and I'm going to leave my y alone. So I've got a y equals a 1 times x minus 2. Was it 2? Wait. Why can't I find anything? Yes, your h was a 2. Okay, still lost it. There we go. Plus a k of 3. Okay, why don't I just look at this paper? Here is 2, 3. Okay, so this comes in an x minus 2 plus 3. So now let's just FOIL this out. First of all, this 1, I don't need to write it anymore. So I've got an x minus 2 times an x minus 2 plus 3. So x squared minus 2x plus 4 plus 3. So I FOILed. X times x. This gives me negative 2x, positive 4, and then positive 3. So my final answer in general form is x squared minus 4x plus 7. So in general form, we have x squared minus 4x plus 7. So again, what did we do? We used both points to find out what a was. And then we use just the vertex to find out what the formal equation was. So let's try it again. My equation is y equals a times x minus h squared plus k. So I've got an h and a k, and I got an x and a y. So my y is going to correspond with this, is a 3 equals a times my x is a negative 4 minus, what is your h? Negative 2. And then plus negative 1. Okay, so notice I keep screaming about changing the sign. What is negative 4 minus negative 2? That becomes negative 4 plus 2. So you took that negative 2, slapped it in there, and changed the sign. So I have a 3 equals a. Negative 4 plus 2 is negative 2 squared. And this becomes minus 1. So I'm trying to get a by itself. I'm going to add 1. So 4 equals a times 4, because negative 2 times negative 2 is 4. So divide both sides by 4, and I find out that a is 1. So I'm going to use this exact same thing and use the vertex and leave x and y alone. So I now have y equals 1 times x minus negative 2 becomes plus 2. And then plus k is just right what's sitting there. So plus a negative 1 is minus 1. So I don't need the 1. Okay, so I'm just going to drop him, which gives me y equals x plus 2 times x plus 2 minus 1. Y equals x squared plus 2x plus 2x plus 4 minus 1. So I FOILed this out. And now y equals an x squared plus 4x plus 3. So that's your equation in general form. This is your equation in vertex form. Okay? So this is your equation in general. This is your, where did it go? That's your equation in vertex. Okay? For the first one, this was your equation in vertex. This is your equation in general. All right, so we are going to, I'm actually going to stop this one, and I'll finish up with a final video.